We've been talking about water a lot, so let's get a little understanding about water. There are three kinds of water, and they're all represented by this jar. First of all, you look in the bottom of this jar, you see liquid water, kind you drink. If it washes under a home, it'll wash the dirt away, it'll knock out stuff, floods are bad, it'll turn the dirt into mud. You don't want liquid water under your house. So that's one kind of water, liquid. The next kind of water is water as a solid. Now, if you can see, right about there, up, is all ice. This bottle's full of ice water. So the ice is floating. When water freezes, it does something nothing else does. Everything else, when it gets cold, shrinks up. Steel, wood, vinyl, all that. But not water. Water expands about 9% when it changes its state from liquid to solid. So we have water as a liquid and water as a solid. When it turns into solid, it expands. And because it expands, it becomes less dense. And because it's less dense, it floats. So that's why all the ice is up in the top of the pitcher. It's also another reason we don't want ice under our footings, because when it expands, it has a lifting force of 50,000 pounds per square inch. This will pick up your house or bust your footings or mess up everything. So, you don't want water as a liquid, and you sure after that don't want it to turn into a solid and expand. But the most dangerous, most damaging kind of water we deal with is not necessarily the liquid or the solid. In fact, it's water as a gas. Those are the three kinds: liquid, solid, gas. This water as a gas is the humidity in this room. And humidity is a difficult thing to understand sometimes, but let's see if I can help you with that. There's a thing called relative humidity. The temperature of the air regulates how much water that air can hold. Hot air can hold a lot of water, and cold air can't hold much water at all. The driest place on the face of the earth is Antarctica. It's not the desert, although it is dry. But Antarctica has no water whatsoever. It is so cold that any water there turns directly to ice. There's just none. Driest air in the world. So, if you had air that is a temperature of 80 degrees, and it has a relative humidity, meaning how much can that 80-degree air hold? If it's 100% humidity, it's holding all the water it can hold at 80. If it's 80% humidity, then it could hold another 20%, but it just happens to be at 80. So let's say we got 80% humidity, 80 degrees. Let's chill that air down to, say, 40. As the air gets cooler, it's less capable of holding water. So as the temperature of the air goes down, the relative humidity goes up. At 40 degrees, it can't hold all the water it had in it at 80 degrees at all. In fact, what happens is the water as a gas transforms itself back into a liquid. And that's exactly what happens here. This bottle of water has nice warm air around it with some humidity in it. It touches the cold surface of the bottle and it chills the air right next to the bottle. And as it chills the air, the relative humidity starts going up and up and up and up until finally it can't hold all that water as a gas anymore, and it turns into a liquid, and we call that liquid condensation. And this whole bottle is covered up with condensation. Now, this water as a gas has destroyed more homes than fire. I'm sure you've all seen the burned out homes here and there. How many rotten homes have you seen? This is how it happens. Water as a gas can go all through the structure of the home, say in the wintertime, till it gets to an outside surface. And when it gets to an outside surface, it chills it with its humidity and causes condensation. And that condensation turns into liquid, of course, and has no way to dry out. It's inside a wall or inside a roof or inside a floor. And that causes a dampness, and it causes rot and mold and all the other bad things. So this water as a gas has destroyed more homes than fire because it can get to places in the home and deposit liquid water that you simply can't dry out anymore. And that's exactly what it's doing here. It's condensating all over this. So, the way you control all three kinds of water is to control the liquid water. That's the starting point. If it's dry, there'll be no ice. If it's dry, there'll be no humidity. You need to keep it dry under that house.